I'm also working on the front heater, and I had the housing from a 71. It's a metal housing, it's not the plastic. And I looked at the core, and the core seems to be okay. I took off the side so I could get to the core, and it needs to be cleaned up and probably painted. I didn't have a blower motor, so I found this blower motor on eBay, and the resistor for slow speed was missing. It's free, but I haven't tried it yet as far as power goes. And this blower motor assembly is an TEQ number 87130-60033. And this is good for 69 through 78 or 77. But I'm finding that it must have some kind of gasket that keeps the blower higher, because if you put it all the way down to the screw holes, the squirrel cage hits the bottom. Now, that's not going to work. So I'm going to have to figure out some kind of gasket that's going to raise this up at least a quarter of an inch, maybe more, if the blower works. If it doesn't work, I'll have to take it apart and see if I can find out what the problem is. It may be brushes, could be the armature is all fouled up, but it'd be a good time to oil felts. The shaft is lubricated by oil felts, and that's a good time to re-oil them. So the heater box itself is a TEQ part number 87150-60032. This is the older style, which I kind of like, with the control knob here for defrost and cabin heat. It's in pretty good shape, so that'll be fun, getting that all together and ready to go. I also have picked up a 78 through 83 Toyota 4x4 mini pickup power steering gearbox, and I've got to pick that up, $150. I'm going to be putting power steering on this truck, and that's the best gearbox to use. Well, I thought I'd blow out this radiator, or this front heater core, and I've got my air compressor set at about 20, and I don't know, I don't think I should have it a little bit any more than that. Do you? Although it's not doing much right now. Maybe set it up some. Probably a little bit more. Well, I had it set up to 60 psi to blow out the outside of it, but I'm going to turn it down to 20 psi and just blow the inside core out. I probably will have to do it with liquid to get everything out of it, but I thought I'd do it just see what was in there for right now. No, that's not going to work. Thing's not big enough. I figured it would fit right in there, or fit on top of it and squeeze down and make a seal, but I don't see that happening. No. Let's see. I don't see anything coming out. Well, let's back up to 60. I don't see anything coming out, so that's good. There's no big chunks in there. I thought I'd do the rest of it just to get the dust off it. There. That should be enough for right now. It's got to be cleaned and painted anyhow. Maybe. I don't know. I kind of like that color. This goes in the engine compartment, so that could be sanded down and painted black. That would be fine. On this blower motor, there's got to be some kind of gasket that goes in on top or in between the housing and the blower motor. Otherwise, that squirrel cage drops down too far and rests on the bottom. And also, it looks like these holes on top of the blower assembly are 1/2 inch, and they're going to have some kind of rubber grommet to go in there, because these bolts are M6 by 125s. So I put some nuts in here just to see if that's a good size, and it looks like that's not a bad fit. And it rotates without hitting anything. So we'll take the size of those nuts and see if I can get a piece of hard rubber or something to go in there for a gasket. As I was lining this up, I see that this cover is bent, so I'm going to have to straighten that out before I put it on. That's 7/16 gap. So now I've got to find some kind of rubber or something that's 7/16 or multiple layers. Well, we're tinkering with the heater blower motor for the FJ40 Toyota Land Cruiser, and I'm going to hook it up today and see if I have low and high speed fan. So I'm trying to clean the connectors, and this connector is for the blower motor itself. It has a ground, a low speed, and a high speed, but sometimes, or most of the time, you can squeeze a little tab on the spade connector and pull it out of the plastic housing. But the ground came out all right, but the high and low speed tabs are not coming out. So I found a pretty neat way to clean those. If you have a pair of hemostats, they have teeth on the inside, and you can take the hemostat and put it on the tab and kind of just pull it out, and it takes the corrosion off pretty good. So I've gotten it so it looks a lot better than it did. I don't want to mess with the tabs too much, because if I break the tab, then I'm going to have to find another spade connector and go through that whole thing. I don't want to do that. So this works pretty good. So I've checked the switch, and I don't have continuity between the battery, the low and the high speed. I did put a new insulation on one of the wires that was bare, and the pins look pretty good. So we may have to undo these little tabs here and get inside and see what the contacts look like. It seems like it's a pretty nice switch as far as the detents go, but I have no continuity. So I'm using my multimeter, which is a Fluke 77 multimeter. And I've got to straighten out the housing on the fan, and I did pick up a power supply, a 0 to 12 or 0 to 30 volt and a 0 to 10 amp. But I thought it was a variable, so that once you had it on you could adjust it, but you have to adjust it first and then shut it off and then turn it back on after you short the leads, and it stays at that adjusted current and voltage. So you can't adjust it once you have it on and on the system. So that's kind of I was kind of looking for something else, I guess, but it was the right price. We'll just have to do with it. So I've been trying to find specifications for this blower. I know it's 12 volt DC, but I don't know what the amperage is. So I took a resistance reading for the motor windings and came up with 0.6 ohms. So I got some formulas for voltage equals amps times resistance and plugged in the values and found 20 amps would be on high and 4.6 amps on low, which would be in the 0.6 with the 2 ohm resistor, which would give you 2.6 ohms, and the amps would be 4.6 amps. But that's kind of funny because the fuse that's in the fuse box for the FJ40 is a 20 amp fuse for the heater circuit. That would be the front heater blower and also the rear heater blower and some other things. So that doesn't make sense, because if it's a 20 amp motor, it's going to blow that 20 amp fuse all the time. So then I found some more specifications for this blower motor. The heating capacity is 3,200 kilocalories per hour. The motor capacity is 80 watts. The motor speed is 2,500 RPM, and the voltage is 12 volts DC. So if you take Watt's law, which is watts equals volts times amps times power factor, and plug in the value, then you get 6.6 amps for the high speed and 4.6 amps for the low speed. So now I can take this power supply and preset it to 6.6 amps and not have any fear of burning up the motor. So I preset the power supply to 12 volts DC and the amps to 6.6 amps. And I've hooked up my test leads to black on ground and red on high speed. Turn on the power supply. And it works. So I'll take the hot side test lead, put it on the low speed windings, and it works pretty good there too. So I'd say the motor's in pretty good shape. I've got to get into the switch now and find out why that's not working. But that's good. It didn't cost very much for this blower motor, as is. So I'm pretty pleased. I hope you liked this video. If you will, like and subscribe. Thanks a lot.